Hey everyone, and welcome to week one of the Saturday EOC Academy. Um, for this week's lesson, we've decided to show you something that you haven't seen in our class so far this year. So Mr. Rimmer and I were discussing what we wanted you guys to be working on this Saturday lesson here, this play posit, and we decided that we were going to push you guys a little bit forward, those of you that are here today for Saturday school. So we're going to be looking at dot plots and box plots, and that's starting to get into some units on statistics. And we will have to do some of this in class as well, but this is going to give you a nice little head start um, and really start to introduce this new idea of dot plots and box plots. Now, this is not going to be completely new because this is definitely something that you would have seen in sixth grade or seventh grade math, but we haven't covered it this year, and it is something that's going to come up on our EOC. So we're going to jump right in, and I'm going to take you right over to a dot plot right here. And essentially, I went into a classroom and I asked, how many hours do you spend playing video games each weekend? And I collected a number of responses. And each green dot on this dot plot represents a student's response to that question of how many hours do you spend playing video games each weekend. So the first thing I'd like you to think about is how many students were asked this question according to this dot plot. Based on this dot plot, how many students did I ask this question to? Right, so I asked this question to 14 students because there were 14 green dots, and we said that every dot represents one student. So based on that, how many students played less than 10 hours of video games each weekend? Using my dot plot, how many students played less than 10 hours of video games? So to answer that question, we're just going to count all of the green dots that are less than 10 hours of video games. The 10 hours is right here. So we'll count all of the numbers less than that. That's 1, 2, 3, 4, 5, 6, 7, 8 green dots. There were 8 students who played less than 10 hours of video game each weekend, every weekend. From those points on our dot plot, we can actually make a list of all of the data, all the original data. So one of the strengths, one of the best things about dot plots is that on a dot plot, we see all the original data. So we know what every individual answer was. We had a 0 and 2 people with 6 hours of video gaming and one with 7 hours and a couple with 8s. And we can write out this list of all of our original data. And what I want to walk you through over the next couple minutes is how do we turn this list of data that we have right here into a box plot or a box and whisker plot, which is a different type of graphical representation for our data. So let's go ahead and do that. The first step to creating a box plot is we have to find the median. And a median, for those of you that don't remember, is the number that is in the middle after we put all the numbers in order. So I've already put all the numbers in order for you, and we've got to find the number that's right in the middle. Okay, so to do that, we'll probably do some kind of counting where maybe we are marking off numbers on each end or an equal amount from each end. So I'm going to go ahead and mark 1, 2, 3, 4 numbers there. 1, 2, 3, 4 numbers there. I'll do a couple more on the left and a couple more on the right. And then I'm left with one on the left and one on the right. That means the median is happening right in between those numbers. It's happening right between 9 and 9. And of course, the number that's right between 9 and 9 is simply 9. The median on this question would be 9. And the next step to creating a box and whisker plot is to find what we call the Q1 and the Q3. And that's really just breaking this data up into quarters. If the median is splitting the data in half, then half of my first half will be my quarter one. So I'm kind of going one, let's see, I'm going 1, 2, 3, 1, 2, 3. That means that right here, this number 7 is going to be my Q1 or my first quarter. And 1, 2, 3, 1, 2, 3. 11 is going to be in the middle on the second half. And I'm going to get my first quarter and my third quarter right there. And this Q1 and the median and the Q3 really help break the data up into equal chunks. You'll notice 1, 2, 3 things here, and between the next 2 points, there's 1, 2, 3 numbers, and between the next two, there's 1, 2, 3 numbers, and there's 3 numbers after it. The last two numbers that are really important in a box and whisker plot are the minimum and the maximum number. And the minimum, of course, is the smallest number in a data set, and the maximum is the largest number in a data set. And in order to create a box and whisker plot, we're going to take these 5 important numbers, the minimum, the Q1, the median, the Q3, and the maximum, and we're going to plot them on a number line. So first, we'll start with our median, and we'll plot it right there on 9 where our median is. And then we'll plot our Q1, which was at 7, and our Q3, which was at 11. And finally, we'll plot our minimum and our maximum at 0 and at 14. So we're going to have all these points, 0, 7, 9, 11, and 14 on the box plot. And the middle 3 lines we use, we essentially create a box out of them. So we're just going to add in these lines to create a box. And we'll extend a whisker out in both directions to the minimum and to the maximum. And we'll end up with this box plot, just looking like this. And when we're looking at a box plot like this, it's important that we know a couple of words related to this box plot besides the one we've already learned. So we know that this thing right here is called the minimum and the maximum. We've got our Q1, we've got our Q3, and we've got our median. But we also have a word that describes the entire distance that this box plot covers. We have a word that describes the distance from 0 to 14, and that word is the range. The range is from 0 to 14. So when we talk about what the range is, we're saying how wide is this graph, and this graph is 14 units wide. We also have another word that we use to describe just the distance of the box, how spread out the box is from 7 to 11, a distance of 4 units, and that's called the interquartile range, or the IQR. And usually we use the IQR as a better indicator of how spread out our data is, because the whole range can be changed by just one number. If we look back at our original data, we'll notice that besides the number 0, the next lowest amount of video game hours was actually 6. So this whole tail that looks way really long down here is really just the result of one data point being at 0. So the IQR, just looking at this middle box, is often a better way for us to describe how spread out our data is. One other thing that I want to point out about a box and whisker plot is that each chunk of this data represents about 25% of the data. And that makes sense because if you think back to what we were doing with when we had our list of data up there, there were 3 data points in each one of these chunks. There was an equal percentage in each one. So even though the chunk that goes from 0 to 7 looks wider, it doesn't mean that there are more people that fall in that data. It just means that those people are a little bit more spread out. So you're going to get 25% of the data here, 25 here, 25 here, and 25 here. And that's why we call these quartiles. This is our first quartile, the lowest 25%, our second quartile, our third quartile, and our fourth or upper quartile. So based on that information, I'd like you to answer a couple of questions. First of all, what percentage of students played less than 9 hours of video games? Right, so if we go to our box plot and we figure out what percentage played less than 9 hours, less than 9 hours is really going to be from here all the way to here, which is 2 chunks of 25. There's a 25 here and a 25 here, and so we're going to get a total of 50%. And now, what percentage of students played more than 7 hours of video games? So more than 7 hours would be from 7 all the way up to here, and that's 25, 25, and 25 for a total of 75%. Finally, on this data, 75% of students played less than how many hours of video games? And to do that, I need to find a 75%. So I'm looking for a number where people are playing less than that number. And I need to add up to 75%. So I'm going to use this 25% right here, and this one, and this one. And that means that the number I was looking for was 11. 75% of students played less than 11 hours of video games. All right, so hopefully, I know that was a lot of information in a very short time. Hopefully you were able to hit pause and take some good notes in there and get some good stuff down. Now I want you to answer a couple of questions on your own. And of course, I'll share the answers as we go. So the first one, this is a data set of test scores. These are the different scores that students got on a test that was given to the ninth period class. So my first question is, what was the high score on the test? Number one, what was the high score on the test? Right, so to find the high score, we're going to look up here at the maximum, and the maximum score here was 102. So next question, what percentage of the class, well, I spoiled it for you. What percentage of this class scored above a 72%? So above a 72% included 72 and everything above it. That was 1, 2, 3 chunks of data, and 3 chunks of data will be 75% of the class. Sorry for spoiling that for you. I will try not to do that again. Number 3, what was the median score on the test? Right, so the median score on the test was 88. The median happened right there in the middle. The median is our middle number. And finally, what percent of the class scored between 88 and 96? What percentage of the class scored between 88 and 96? All right, so that last question between 88 and 96 was 25%. It was just one chunk of our box. Cool. One more question for us to look at, and there's going to be 3 follow-up questions here as we look at this one situation. And this is called a stacked box and whisker plot. It's got 2 box and whiskers right on top of one another. And what we're doing here is we're comparing wooden and steel roller coasters based on how fast they can ride, on how fast they can go. And so there's a total, it says 145 roller coasters in the United States that are represented on this graph or on this chart. And we're going to answer some questions about this chart. So first of all, I'd like you to think about what type of coaster has more observations. That is, which of these 2 coasters, are there more wooden roller coasters or are there more steel roller coasters? So this is a little bit of a trick question, because one might think that because the steel roller coasters are the graph is wider, that it represents more roller coasters, but we don't really know how many roller coasters. We know that there's a total of 145, but we don't know how many of them are wooden and how many of them are steel. So the best answer here is cannot be determined. And that, in fact, is one of the weaknesses of box and whisker plots. On a box plot, we don't know how many observations there are. We don't know how many pieces of data there are. If we think back to the dot plot was kind of cool because it shows us all the individual data. The box plot doesn't show us the individual data. It only shows us kind of a summary of all of the data. So let's go to our next question. Which type of coaster has a higher percentage of coasters that go faster than 60 miles per hour? So which one has a higher percentage of coasters that go faster than 60 miles per hour? So to answer this question, we have to figure out where 60 is on each one of these box plots. And 60 is right there on the box plot. And so for the wooden roller coasters, only 25% of the data is past that. And for the steel roller coasters, there's 50% of the data. So which type of coaster here is going to have more that goes 60 miles per hour? It's going to be the steel roller coasters. There's 50% of them go faster than 60 miles per hour, whereas in wooden, it's only 25%. All right, last question here. Which type of coaster has a higher percentage of coasters that go faster than 50 miles per hour? If we come back and think about 50 miles per hour, which one has more 50-mile per hour roller coasters? So to do that, we've got to figure out where 50 is on each of these box plots. And we're going to tell that for 50, we're getting 3 chunks of data here. This is 75%. 75% of all wooden roller coasters go faster than 50 miles per hour. For the steel ones, we have 1 chunk, 2 chunk, 3 chunks. That's also about 75% of steel roller coasters go faster than 50 miles per hour. So the answer here is about the same. They both have about the same percentage of 50 mile per hour or faster roller coasters. And that's it for box plots. So this was a little bit of a long play posit, but hopefully you were able to get some good information about box plots. And now you are going to kind of close this up and start a little activity to practice using what we just learned about box plots. I hope this video wasn't too stressful for you, and make sure that you leave some feedback at the end of it. All right? Hope you enjoy the rest of your Saturday. Bye.